Chapter 13, Annuities and Sinking Funds. In this video, we'll be discussing annuities, an ordinary annuity and an annuity due. We'll differentiate between contingent annuities and annuities certain, and calculate the future value of an ordinary annuity and an annuity due manually and by table lookup. An annuity is a series of payments. The term of an annuity is the time from the beginning of the first payment period to the end of the last payment. The future value of an annuity is the future dollar amount of the series of payments plus interest. The present value of an annuity is the amount of money needed today to invest in order to receive a stream of payments for a given number of years in the future. A lot of times when we talk about annuities, we think about winning a lottery. So if you win $1 million in the lottery, you go down to the state office in Raleigh and you turn in your ticket. Do you get a check for $1 million? No. You normally get them in a stream of payments, an annuity. By paying winners an annuity, lotteries do not actually spend $1 million. The lottery deposits a sum of money into a financial institution, and the continual growth of this sum through compound interest provides the lottery winner with a series of payments. I really like this example in the book with coffee. I don't know about you guys, but I like to drink my cup of coffee. So the Boston Globe did an article about the cost of living a cup a day. And it says that we're going to assume that each person drinks 3 cups a day of Dunkin' Donuts coffee at the cost of $1.65 per cup. So 3 cups of coffee times $1.65, they're spending $4.95 a day on coffee. So if you don't do 3 Dunkin' Donuts, think of 1 Starbucks large, whatever, just say $4.95 a day. For a 5-day week, a person would spend $1,287 a year on coffee. If that person brewed coffee at home, the cost of the beans per cup is 10 cents, giving you an annual expense of $78, saving you $1,209 over the year. If you give up drinking completely, you would save $1,287. So in this example, it's showing you that if you brew it at home, then you would save $1,209. Over 30 years, if you just saved $1,209 a year, you would save $36,270. If you put that in the bank with a 6% interest rate, you would save $101,600. 10% would save $230. If you give up coffee completely to save that $1,287 per year, in 30 years you would have saved $38,000. If you put it in the bank and earn 6% interest, you'd save $108,000. 10% would save you $245,000. So that's a lot of money you can save by not going to Starbucks or to Dunkin' Donuts for coffee. So the future value of an annuity at 8%. So if we have an annuity and we're talking about the future value of it, we're looking at the future dollar amount of this series of payments plus interest. At the end of the period, $1 is still worth $1 because it is invested at the end of the period. At the end of period 2, an additional $1 is invested. The $2 is now worth $2.08 because the $1 from the first period earns interest, but not the $1 that's invested at the end of the second period. At the end of the third period, an additional $1 is invested. This $3 is now worth $3.25. Remember, the last $1 invested earns no interest because you're investing it at the end of the period. So annuities are classified as either contingent annuities or annuity certain. Contingent annuities have no fixed number of payments, but depend on an uncertain event. For example, life insurance payments that cease when the insured dies. Annuities certain have a specified number of payments, for example, mortgage payments. Based on the time of the payment, we can divide each of these major two annuity groups into further classifications. An ordinary annuity makes regular deposits or payments at the end of the period. Periods could be months, quarters, years, etc. An ordinary annuity could be salaries, stock dividends, and so forth. An annuity due is regular deposits or payments at the beginning of the period, such as rent or life insurance premiums. It's very important that you understand the difference in an ordinary annuity and an annuity due, because it makes a difference in the interest calculation. If you have a monthly annuity that is an ordinary annuity, then it is done at the end of the period, January 31st. If it's an annuity due, it's at the beginning on January 1st. So notice the difference between the two. So to calculate the future value of an ordinary annuity manually, there are 4 steps. For period 1, no interest calculation is necessary because we're putting the money in at the end of the period. It's an ordinary annuity. For period 2, we calculate interest on the balance, add the interest to the previous balance. Step 3, add in the additional investment at the end of period 2 to that new balance that you had already calculated interest on. Then repeat steps 2 and 3 until the end of the period is reached. So for example, find the value of an investment after 3 years for a $3,000 ordinary annuity at 8%. Ordinary annuity. Payments are put in at the end of the period. So step 1, end of the year, $3,000. No interest calculation is necessary because we're investing the money at the end of the year. So year 2, we have a $3,000 balance. We need to calculate 8% interest on this $3,000. So we have $240. Add the $240 to the $3,000. Our balance is $3,240. Now add in your year 2 investment of $3,000. So our balance is $6,240. That is the balance to which to calculate the 8% interest, or the $499.20. Add $499.20 to $6,240. Your balance is $6,739.20 before your year 3 investment. Add in your year 3 investment and you are now at $9,739.20. Make sure you're adding these investments after you calculate interest on the previous balance. You can also calculate the future value of an ordinary annuity by table lookup. The future value of the ordinary annuity equals the annuity payment at each period times the ordinary annuity table factor. Another table. Aren't you excited? I know you are. Calm yourself. Calm yourself. Table 13.1 we will be using. So calculate the number of periods and the rate per period, just like we've been doing. If it's annually, it's once a year. If it's semi-annually, it's twice a year. Quarterly, 4 times a year. Make sure you're looking up the rate per period. If it's an 8% rate and it's compound and it's quarterly, then it's 2% per period. Look up the periods and rate in the ordinary annuity table. The intersection gives the table factor for the future value of $1. Multiply the payment each period by the table factor to give you the future value of the annuity. So this is the table. It's been reproduced here for you. So remember, we had 3 periods at 8% because it was annually. So our table lookup is 3.2464. So finding the value of an investment after 3 years for a $3,000 ordinary annuity at 8%. We have 3 periods because there are 3 years and it's compounded annually. Our rate is 8% because it's compounded annually. So our table factor times our annuity amount of $3,000, the future value is $9,739.20. The same thing that we got when we calculated this manually. Now, Calculating the future value of an annuity due manually, not an ordinary, but an annuity due. Remember, an annuity due, we're putting in our investment at the beginning of the year. Calculate interest in the balance for the period and add it to the previous balance. So we're putting money in on January 1st, and it's in there for the entire year. So for the first year, we need to add interest to that balance. Add the additional investment at the beginning of the new period to that balance. Repeat steps 1 and 2 until the desired period is reached. So manually, find the value of an investment after 3 years for a $3,000 annuity due at 8%. So we have our beginning balance of $3,000. It's in the bank the entire year. So it earns $240 of interest in the first year. So our balance at the end of the year is $3,240. We put in $3,000 more at the beginning of year 2. So our balance is $6,240 for the entire year. Calculate the interest on that is $499.20. $499.20 plus the $62.40. Our balance for the entire, our balance once we add interest is $6,379.20. The new year, we add $3,000 to it. So for our entire year, our balance is $9,739.20. So at the end of year 3, we add interest to that $9,739.20. So at the end of year 3, our interest is $10,518.34. Remember, for the ordinary annuity, our total investment was only worth $9,739.20. But with the annuity due, it's $10,518.34 because we're putting money in at the beginning of the year and it's in there for the entire year to earn money. Whereas the ordinary annuity, we're putting it in at the end of the year. You can also calculate the future value of an annuity due by the table lookup. Now pay close attention to this because there are 4 steps involved with this. 1, calculate the number of periods and the rate per period and add 1 extra period. So if we had 3 periods because it was 3 years, we need to add an additional period to make it 4. Look up in the ordinary annuity table the periods and the rate. This intersection gives the table factor for the future value of $1. Multiply the payment each period by the table factor. Then subtract 1 payment from step 3. So the future value of an annuity due is annuity payment each period times the ordinary annuity table factor minus 1 payment. So our example, find the value of an investment after 3 years for $3,000 annuity due at 8%. Our number of periods is 3. We need to add 1 to it to get 4. So we have 4 periods. Our rate is 8% because it's only 1 time per year. So our table factor is 4.5061 times 3,000 is 13,518.30. But we have to subtract that extra $3,000 period that we added in. So our future value is the $10,518.30 that we calculated when we did it manually.